Hello everyone, for today's video we are going to use the Gauss-Jordan elimination method to find the inverse of a matrix. In this case, our matrix A is -4, 0, 0, 0, 8, 13, 0, 3, and 5. Okay, so the first step here is to copy our matrix as it is. 4, 0, 0, 0, 8, 13, 0, 3, 5. We need to add this line, and after this we write our identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so now we need to perform the Gauss-Jordan elimination method. First, we need to get rid of this -4 and turn it into a 1. So for that, we make -1/4 of R1. With 1, 0, 0, -1/4, 0, 0. Okay, now we got this column done. We need now to turn this 8 into a 1 and this 3 into a 0. For that we make this 1/8 of R2, and for this row we make the 3 times R2 plus R3. This R2 is when this entry is a 1. After that we get the following matrix. Okay, so the next step is to turn this into a 1 and this into a 0. For that we need to perform 8 times R3, and for this -13/8 of R3 plus R2. Okay, we will continue in this side. After that we get 1, 0, 0, 0, 1, 0, 0, 0, 1, which is our identity matrix on the left side now. At the beginning we have it on the right side, and on the right side we will have our inverse matrix, which is 1, 4, 0, 0, 0, 5, -13, 0, -3, and 8. So our final answer is the inverse of matrix A equals -1/4, 0, 0, 0, 5, -13, 0, -3, 8. This is our final answer. Now, for problem 2, we are going to find the values of the unknown constants for which A is a symmetric matrix. Here we have our matrix A, which is symmetric, and we need to find the values of A, B, and C. For that, first we need to get a transpose of A. The transpose consists on switching the rows with the columns. So we get as our first column the first row, which is 2A minus 2B plus B plus C. Now the second column will be the second row, which is 3, 5, A plus C, and our third column will be the third row. 0 minus 2 and C. This is our first step, because with this we now can see that this is an upper triangular matrix, and as our matrix A is symmetric, we can determine that the lower values of this diagonal will be equal to the upper values of the diagonal. So with this, now we can get a system of equations which will be A minus 2B plus 2C equals 3, 2A plus B plus C equals 0, and A plus C equals minus 2. We can see that this comes from this value equal to this value equals to this value, and this value equals to this value. Okay, so now we only have to solve this system of equations, and for this problem we will use Gauss-Jordan elimination method. So we need to get a matrix. First, we need to get these values to 0. By performing these row operations, minus 2 times R1 plus R2 and minus R1 plus R3. Now we get this matrix. Now we need to make this 5A1 and these two numbers zeros. For that, we will divide row 2 by 5, and this we 2 times R2 plus R1 and minus 2 times R2 plus R3. After this we got now we need to multiply this by 5. And finally, we need to turn these two values into zeros. By multiplying minus 4 times R3 plus R1 and 3 over 5 times R3 plus R1. Okay, so after this, we now, on the left side of this line, we get our identity matrix. And at the right part we will have our answer. So our final answer is x1 equals minus 11, x2 equals 9, and x3 equals minus 13. And this is it.